Hi everyone, I am Abdul Khader from 3rd ECE department from Sri Venkateswara Engineering College. I am here to present project of microwave wave simulation which I have done in my MSc internship. Let me tell what are the things I have learned in internship and what are the things required for this project. These are the things I will explain in this project demo. Those are requirement, what is embedded systems, microcontroller and microprocessor, Pixem Lab and CLCD, matrix keypad, and what is micro oven, ISR, timers, what are the timers we are using, and at last project implementation demo. Let me explain one by one. Initially, what is micro oven? Micro oven is used to heat food using microwave, which is in the form of electromagnetic waves. There are several modes in micro oven. Those are divided as four. Those are micro mode, grill mode, convection mode, and start mode. Let me explain briefly about those type of modes. First, micro mode. This mode is used to cook food in traditional way. It uses a maximum power of 900 watts, means the power consumption required for this mode is 900 watts. In this, maximum time you set for cooking is approximately 60 minutes. Coming to the second mode, it is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the only difference is it is used to cook the bread and meat. In this mode, we can set time as per cooking time of the meat. So as per our requirement, we can set the time. Coming to the third mode, it is convection mode. In this mode, user can set oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. In every microwave oven, defaultly there is 3 minutes. In some ovens it will be 5 minutes also. For our project it will be 3 minutes, means 180 seconds. After preheating is done, then user can set the time as per the requirement. Coming to the requirements, we have these things in order to do this project. That is knowledge in embedded C, MPLAB IDE, XE8 compiler, Pixem Lab, and the peripherals in the Pixem Lab are PIC16 F877A. It is the microcontroller of our project, and CLCD 16 cross 4 CLCD we are using in this project, and tactile switch. Tactile switches arranged in row and column manner are formed as matrix keypad, that is MKP, and timer. Coming to the timer, we are using timer 2 in this project. Now let me tell about what is embedded systems. Embedded systems is a combination of any hardware and software which is intended to do a specific task. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. Means embedded system is only created for specific task only. We do not use this embedded system for multiple purpose. Whereas GPS is we can use for general purpose system. Means we can use for multiple purpose. There are several types in embedded systems. Let me explain one by one. That is standalone systems, real-time systems, and networked system and mobile system. This is the components every embedded system should have. That is taking inputs from the ports and System means processing, memory and other devices, and output will become. First, standalone system. Under standalone system, first is slave system. These systems are not intelligent even though these are embedded systems. These systems cannot take action by their own. Means even though these are embedded systems, these are not intelligent. Means not self-controlled. Example is semi-automatic washing machine. Means it will do the washing purpose, but it is not automated without any user. So we need a user to control this. So we can tell this is a slave system which is not intelligent embedded system. Coming to the second, it is independent system. Name itself telling that independent means these systems can take action by their own and no need of user. Example, Google car means automated Google cars, driverless car. In this is also a embedded system, but there is a no need of user. Automatically with the machine intelligence it will work. These type of systems are called independent systems. And second type of system is real-time system. These systems are time-bound systems which will take actions on a specific time. And failures in these systems are not acceptable. Means failure rate is zero. Means definitely should occur. Under this there are three types: hard real-time and firm real-time and soft real-time. Example for this real-time systems are airbag systems. This is the airbag system. And third type of system is networked system. The system which are connected to the network are called networked systems. Example, home security system means connecting the home through IoT. We can tell it as an example. Means all the electronic devices connected to a network. And coming to the fourth, it is mobile system. The system which are movable are called mobile system. Means an embedded system which can be movable, we can call it as mobile system. Example, robots. Robots are mobile systems, so we can call it as mobile system. This is the block diagram. Let me tell briefly this. For any project we need software, right? So this is the software, and main part is microcontroller or microprocessor we need, and some peripherals like memory and sensors and auxiliary systems and activators. Human interface means user. These are the some peripherals in block diagram. Okay, how to choose embedded systems? Let me tell. We should choose an embedded system that should have the following characteristics. Means embedded system should have low power consumption and cost efficiency means low cost. Efficient use of processing power, reliability, and efficient use of memory. Memory also efficient. We should take care of these characteristics while choosing embedded system. And coming to the main peripheral of project is microcontroller and microprocessor. An integrated circuit means IC, which is capable of being programmed to perform a specific task, is called microcontroller. It has a design restrictions such as memory size, input-output capabilities, peripheral functions, etc. Choose a microcontroller based on applications, performance, and price and availability of tools and special capabilities. Means we have to choose microcontroller in such a way that it should suitable for our project. Microcontroller was microprocessor. What is the difference among them? Microcontroller. In microcontroller, all components will be in a single chip. Means every peripheral and all are included in a single chip. So it will be less flexible and less design complexity. And coming to the microprocessor, all components are assembled separately. Means CPU will be different and the memory elements are different and different sensors are arranged in separately. So we can say that it is more flexible and more design complexity. Pixim Lab. We are using Pixim Lab, right? So these are the architecture means in PIC16 F8778 is a microcontroller of a project. These are the peripherals attached to it. Those are buzzer and digital keypad and matrix keypad and CLCD character liquid crystal display. These are the things. Temperature sensors. These are all connected to our microcontroller. And syncing and sourcing circuits. Let me explain briefly about this syncing and sourcing circuit. If you see this, the current is flowing in this direction from microcontroller to load, right? So we can say that means current flowing from microcontroller to load means it is output to microcontroller with respect to load means this load is acting output with respect to microcontroller because the current is flowing in this direction out from the device. This process is called current sourcing. And current, coming to the current sinking, from the VCC 5 volts current is coming and it reaches to load, and from load it is going to microcontroller, right? So load is act as source for the microcontroller. Here in this sourcing process, microcontroller act as source for this load. These are the two types of syncing and sourcing circuits. Coming to the main peripheral is CLCD. CLCD means character liquid crystal display. In Pixim Lab, there are two types of displays. It is 16 cross 2 display and 16 cross 4 display. For our project, 16 cross 4 display will chosen. 16 cross 4 means there are 16 columns like 1, 2, 3 and 4 things. These 16 characters will be in ASCII form. It display ASCII characters and some special characters. Means, as I said, everything is stored in ASCII form and shown in this CLCD screen. There are two types of communication modes in this CLCD. It is 4-bit mode and 8-bit mode. Coming to our project, we are using 4-bit mode. Coming to the next peripheral, it is tactile switch. It is the diagram of tactile switch. These are the terminals. We can choose two types of tactile switches. These are pull down resistor circuit and pull up resistor circuit. Let me explain briefly about these things. Power is coming from VDD. Let me take two conditions to make you clear in this concept. In first case, if the switch is open, then power from this will not come to the microcontroller. So we can say output is 0. Okay. Consider second case. If the switch is closed, current will come to here and it reaches to microcontroller. So we can take it as 1. Whereas coming to pull up resistor, it will simply opposite to pull down resistor. VDD from VDD current will coming. When switch is open here, microcontroller will be on. When switch is closed, the output will be 0 because it will directly connected to ground, right? When switch is on, it directly connected to ground, so output is 0. These are the two types of circuits. Tactile switch is a switch whose operation is perceptible by touch, means it is sensible to touch. According to our need, we have to click this switch. This is a switch used to select mode of operation and to enter temperature and to enter time in our project. Means at the last I will show the demo, then you will get clear idea. Means we have to choose 1, 2 like that in order to choose the modes and to select the time and to keep the temperature also. This switch will produce a bouncing effect when switch is pressed. What is MKP? MKP is matrix keypad. This keypad in which number of tactile switches connected in row and column concept. This is used when more number of user inputs are required and still want to save some control input output lines. Means in this line, keypad is nothing but tactile switches arranged in row and column concept. Means see there, these are the tactile switches arranged in column and row manner, right? This column and row arrangement of the tactile switch is called matrix keypad. These keypads are most commonly used in telephone, calculator, digital locker. As we know that in every these devices we are using switches, right? So all the switches are made in the form of tactile switches and matrix keypad form. And what is interrupt? An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device request of MCU or MCU to stop the process. Means interrupt is nothing but it is a process of microprocessor in which internal or external devices we have to request for microprocessor unit in order to stop the process when the interrupt occur. Then the MPU or MCS identify the request, attend to the request, and goes back to the processing where it was got interrupt. Means wherever we got interrupt, it will go to there and check it. Polling. It is the process where the computer or controlling devices wait for an external device to check the read lines or state, often with low level hardware. What are the disadvantages of this polling process? Its loss of event may occur during the polling. Means there may be loss and poor response and less power management. Means there is a low power management. Classifications of interrupts. Let me tell some interrupts. Interrupts. Those are two types initially hardware and software. And under hardware there is a non-maskable interrupt and maskable interrupt. Under again it maskable interrupts there is external and internal interrupts. These are the types of interrupts we are facing. ISR. ISR is interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register content that may affected by the code in the ISR. It must terminated with the instruction of RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables a global interrupt enable. Means when it is being executed, then this ISR will disable the global interrupt enable. Place the address from the program counter on the stack. Return from interrupt. After doing all this process, it will return from interrupt. All this process will done with the help of ISR, interrupt service routine. Timers. These are the most important peripherals in our project. There are two types, timer 0 and timer 2. We are using timer 2 in our project. Let me explain about brief. Timers is an important application in any embedded systems, which is a default peripheral which maintain the timing of an operation in sync with a system, clock or an external clock. It has many applications such as measuring time and generating delays, etc. Timer and counter is a software designed to count the time intervals between the events. Means in order to measure the time, we can use timers and counters. Resolution. These are some vocabulary we used under timers. First is resolution, which is also called as register bit. Means what is the register bit is also called as resolution. 8 or 16 bit. Tick. What is tick? Tick is referred as the change from one number to another number. Means the time referred to change from one number to another number. It may up count or down count. It means it will decrease or increase. Next is quantum. Quantum is which depend on the system clock settings is a measure of time which is responsible for the time. Sorry, tick. Scaling may be pre-scalar or post-scalar. Examples of this scaling is 1 is to 1 or 1 is to 8, etc. There are several modes of timers. Those are PWM, pulse width modulation and pulse generator, etc. Let's get into the demo, our project demo, in order to understand in a well manner. First, we have to load the hex file of code we written in XA8 compiler. First, it will show like this. As I said, from the switches we have to choose one mode. First mode is micro mode. I will choose. Here it's showing power 900 watts required for doing this micro mode. It's asking for us to enter time. Let me enter a 5 seconds for our convenience. After that, we have to enter hash key, means it will on, fan is turning on, and this showing time. Okay, you have seen time up, means after the count has ended, it will show time is ended, means as per our requirement we have to choose the time. And coming to the second mode, it is grill mode. In grill mode also, it is showing enter time. The specialty of this grill mode is we are specially using this grill mode to cook meat and bread. For our convenience, let me enter a 6 seconds, and we have to enter that using hash key. It's showing time and its fan is on. It is showing time sound. Coming to the third mode, it is convection mode. First, as I said in theory, it asks for temperature. First we have to set temperature as per our requirement, whatever we want to cook. After that we have to enter hash key. As I said, the preheating time for the microcontroller is defaultly 180 seconds, means 3 minutes. We have to wait until this 170 seconds. Up to this I will explain some peripherals in this board. This is the MKP matrix keypad, which I have discussed in my theory. What these are the keys and hash and enter keys. This is the fan used for cooling purpose, and this is the buzzer which gives sound whenever time up. And this is the ports, uh, and this is the main peripheral as I discussed in my theory, that is PIC16 F877A microcontroller of our project. And this is the EEPROM, means this is the act as storage device in our project. These are relays, means we know that relay is a electrical switch used for on off purpose. This is the one key reset key, means whenever we click this key, the project will start from initial, means from the power starting. Coming to this, we have to choose 20 megahertz frequency for clock for our project. This is, as I said in theory, there are two types of CLCDs. CLCDs, those are 16 cross 4 and 16 cross 2. For our project, 16 cross 4 is required. Means 16, there are 16 columns, see 1, 2, 3 like that up to 16, and there are 4 rows, 1, 2, 3, 4. This is mean 16 cross 4. We have to wait still 70 seconds more. And this is the RB3 switch, which is used to check whether the door is open or closed for our micro oven. Means whenever we click this, it will show as door is open, and whenever again we click this, door will close. This will give the indication. Let me show after this time is ended. Our preheating time is ended. After the preheating 3 minutes, it will ask us to enter the time. For our convenience, let me enter is 6 seconds. After that, we have to, or else if we want to clear, we can use this asterisk. If we click the asterisk, it will show 0. Okay, we can use this switch as like that. Let me click at 20 seconds, 29 seconds. You can see that fan will automatically on and time is running out. There are several switches in order to use. Those are start and pause and stop. For example, let me show that start. If you click the 4, it will increase it 30 more seconds. In this convection mode, there is one thing we have to choose. Defaultly, it will be 30 seconds here. Whenever we click the switch 4, it will increase 30 seconds more. Means when here now 30 seconds, right? After clicking this, it will become 1 minute. Okay? Means for every one time clicking switch number 4, it will increase 30 seconds. After that, if you want to pause the process of heating, we can use this switch 5. Let me click switch 5. Yeah, you can see that timer is stopped and the fan is stopped. Means the process of heating is stopped. Whenever we click the 5, that is pause. If we want to resume, we can click this 4 switch. Now it will not increase the timer by 30 seconds because whenever the process is pause, if you click the switch number 4, then it will automatically resume the process. Let me click this 4C. Timer is continued from wherever it is stopped and fan is automatically turning. After the completion of time, it showed time up, right? Now coming to the fourth mode, it is start mode. I have to click switch number 4. Defaultly, time will start from 30 seconds. As I said, RB3 switch is used to door open and close. Let me click this RB3. It's showing the door status is open. Please close the door. Means whenever the door is opened, then it will show the status like door is opened. Please close the door. Actually, the buzzer sound will on, but I hope you will listening that buzzer sound also. If we click again this RB3 switch, again it will release the door is closed from the CLCD. Means whenever we want to open the door, we have to click the RB3 switch. It will show the as okay, as time is up, it will showing time up. Okay, let me show once again this door how to open other. We have to choose start mode. When the timer is on, we have to click the RB3 switch in order to open the door. When we open the door, what it said, door is opened, please close the door. Again we have to click the switch RB3 in order to release to close the door. That's it for this project. I hope I covered all the points which I have learned. Let me tell one thing. I have done a real-time project microwave oven simulation in this internship with the knowledge whatever I have learned from MRC internship. I am very much excited to learn this new stuff regarding embedded systems. Understood how the peripherals like microcontroller timers are integrated in order to form a real-time project. It is microwave oven. And I want to specially thank MRC Group for providing such a great internship, and I want to thank especially for our mentor Rajini Shinde ma'am for her great session. Thank you all.